All right, so the last 10 MCQs, so section B basically, and the only jugars that you can remember for this is that if one is wrong, if the statement one is wrong, then you pick what? You pick C for sure. You don't have to even read the other statements. If statement two is wrong, then you go for D, I believe. Yeah, you can check this from the table. Anyhow, I'm sure most of you, if not all, know this by now. So let's begin. Compound Q contains 40% carbon by mass. What could Q be? So this is kind of boring, in fact, because now what you have to do, you calculate mass of carbon. Hamza, do you have a calculator?
Yeah, I have one.
Mass of total. So in fact, this would just be your MR, and hopefully Hamza is already calculating by now. So yeah, you do that into 100,
Yeah.
which basically means that you can write this formula as 12, because that's the AR of carbon, into, let's say, N, where N is the number of carbons, upon MR of the compound into 100. So it's kind of boring. You have to just
One is correct.
so one is correct. For two,
Or two is not correct.
2 is not correct, which means your answer is what? Your answer is D. Automatically D. So you can move on. So we're just simply just popping it into this formula. Anyhow, a container is partially filled with hot water, sealed, and left to cool. Which statements are correct? 1. As the temperature decreases, water molecules lose kinetic energy, and that's fine. Because well, temperature decreases, they start to move. They're not moving as fast then. Obviously, if their speed goes down, kinetic energy goes down.
SN, the very definition of their temperature decreasing is that their kinetic energy is decreasing.
Yes. So, okay, sorry, Hamza. Yeah, that. As the temperature decreases, more water molecules move from vapor to liquid, and I believe that is fine as well. Because if you have hot water, some of it would have vaporized. Since it is sealed, so that would have kind of collected under the whatever the lid is, and as the temperature decreases, it just moves back to liquid. It cools down. As the temperature decreases, the vapor pressure of water decreases. And Hamza, I believe this is correct as well.
Yeah, because PV is equal to nRT, so pressure is directly proportional to temperature.
Yeah, so you can look at it like that, as Hamza said. Another way to think about it is like, well, you have less water vapor anyways. So like even just the vapor,
Yeah.
if you just want to look at it very simply, vapor goes down because it just goes back to liquid. You have less vapor, obviously you'll have less vapor pressure. Anyhow,
Yeah.
ammonia and chlorine react together in the gas phase, and you have this particular equation. Which statements are correct? Ammonia behaves as a reducing agent, which means it has to reduce the other thing, which I believe is fine because chlorine goes from 0 to -1.
To minus.
So that's fine. It does behave as a reducing agent because it reduced chlorine. Ammonia behaves as a base, and we can say so, I believe, because ammonia went to your ammonium ion. So it basically in a way it gained H positive to go to the ammonium ion, and if you're gaining H positive, you can say it behaved as a base. Bases are proton acceptors or gainers. The oxidation number of hydrogen changes, not really. If you
doesn't.
Yeah, so if you wanna look at it, if you use green, here hydrogen would be here. Ammonia is what? Plus. Can we look at it like that in terms of oxidation numbers?
Wait, let me see this. Ammonia, what? Ammonia is positive.
That's what I'm thinking. I can't seem to remember. Is hydrogen, if hydrogen is
No,
positive?
nitrogen is positive. Hydrogen is positive and nitrogen is negative over here.
Okay, we'll take
The
your word.
common misconception is to confuse NH3 with hydrides.
Yeah, yeah,
Hydrides have a negative H, but that's not the case in NH3.
yeah, yeah. So that's good. So hydrogen would only have a negative oxidation state if it's a metal hydride. So something like NaH would have -1 and +1. But apart from that, if it's not a metal hydride, it will always be +1. So it's 3. So this would be +3. Ammonia is hence -3 to balance that. So here you have -1, you have +4, and you have -3. So you can see hydrogen, the oxidation number of hydrogen doesn't have to change to balance it. So 1 and 2, right? Kya hota hai? That's B.
B.
Okay. In which
Just by the way, just
yes,
one more thing you should mention. If you got 1 correct, then instead of checking 2, first check 3. Because if 3 is wrong, then that automatically lowers your option base, right? And if 3 is correct, then you automatically know it's A. So you don't have to do that extra step.
exactly. So you can do that as well. Shortcuts. Whoa. Okay. 34. In which reactions does NH3 behave as a Bronsted-Lowry acid? So it behaves as a Bronsted-Lowry acid if it donates proton.
NH.
So
Yeah.
it's basically your H positive ion. So what's happening here? NH3 goes to NH2 negative plus NH4 positive. So in a way, if you think about it, you have NH3, you have NH3. You have, if you look at this, you have 2 moles of NH3, and what happens is, in fact, to better explain, let me just draw this in a different color. Okay. So you have NH3. Let's say, and now what happens is iska ek NH3 chala jata hai, and this forms NH2 negative, and now this forms NH4 positive. So in a way, one of the NH3s at the least has donated H positive. So we can say that NH3 does behave as an acid in this case. One NH3 is behaving as an acid. One of the NH3s is behaving as a base, but they didn't ask whether it's behaving as a base. They're like, is it behaving as an acid? And yes, one NH3 is behaving as an acid. If you look here too, it's just accepting H positive. So whether H positive is going from here to here, so that's 2 would be wrong. And if 2 is wrong, your answer is automatically D, I believe.
Yeah, it's D.
Yeah. Chlorine reacts with hot aqueous sodium hydroxide. Which oxidation states does chlorine show in the products of this reaction? Well, -1 is always there. That's for sure. Now, if you think about this, so chlorine, if what were the states that chlorine used to show? It used to show -1 if it was oxidized. So it used to show +1, +3, and +5, I believe, right? If I remember correctly.
As far as I remember, this was the disproportionation reaction. So
Yes.
-1 was when it formed a product as NaCl,
Yes.
and when it formed a product as NaClO, if I remember correctly, the oxidation state was +3. No, it was +1 once again.
So NaClO.
And when it formed NaClO3, then it was +5.
Yeah. So here will be +5. So, so 1 is right, 3 is right,
Yeah.
and that
No, wait.
clearly
How is 3 right? When is chlorine +1?
+1 NaClO. But again, it's reacting with hot aqueous NaOH. So with hot aqueous NaOH,
Yeah.
it would only make NaClO3.
Yeah, that would be 5 positive.
But that's interesting though, like, because at times they try to trick you with these stupid questions. वैसे, at times, I mean, like, is majority of NaClO3 made, or is all of is it only NaClO3? Like,
As far as I know, if it's hot aqueous sodium hydroxide, then this is the product of the reaction.
All right, all right. And since it's not it's not positive 3 anyways, right? There's no reaction where it's positive 3, correct?
Yeah, not as far as I know.
Yeah, well, if you can't remember AS, I definitely do not. Anyway, so 2 is wrong, so you can just conclude with D anyways. And Hamza already offered some explanation why it can't be 3, because it's hot aqueous anyway. Anyhow, in which different forms does nitrogen exist in compounds? So does nitrogen exist in compounds? So bonded by a triple covalent bond, yeah, well, if it's you have HCN,
And
so you can, so it exists like that, as part of a cation. So can we think of a place where hydrogen,
NH4 positive.
yeah, so NH4 positive in an oxidation state of +5, +5
HNO3.
HNO3. Okay, nice, nice. So oxygen is -2, which makes it -6, +1, and to balance it, this obviously has to be +5. Yeah, so this is A. Okay. Polyethylene and PVC are examples of addition polymers. Which statements are correct? On combustion, PVC can produce carbon monoxide, carbon dioxide, and hydrogen chloride. So PVC, if I remember correctly, was just this. I mean, this is one monomer. Obviously, आपका फिर, uh, it, it just the double bond breaks for it to form the polymer. PVC was this, right?
Yeah, PVC was this.
Okay, so if it combusts, so well, I hydrogen chloride. I suppose so. I suppose it can produce. It can. I mean, it can produce carbon monoxide, carbon dioxide. These two are fine, depending on how much it combusts. Can it produce hydrogen chloride? It does have hydrogen. It does have chlorine. They're not directly attached to one another. Um, but if you burn it, might as well happen though. What do you think?
Yes, it might happen. I think the trick in this question is to figure out whether the rest of the two options are correct and then come back to this one.
Very jugaad method. Anyhow, so let's come back to this one. This one is 2/3 right. 1/3 of it we're not too sure of. Anyhow, when polyethylene is buried in a landfill, it will not significantly biodegrade. It will not. If for stuff to be biodegradable, you need condensation polymers, so that hydrolysis and stuff of that sort can happen. And generally, like polyethylene, you have plastic. You put plastic in the landfill, it's not going anywhere. Don't worry. Anyhow, so the empirical formula of an addition polymer is same as that of the monomer. I believe that is fine as well, right? So the empirical formula is basically the ratio of, like, let's say carbon to hydrogen, or carbon to hydrogen to chlorine in this particular case.
Yes, but Ehsan, if you consider this very double bonded monomer, if you're making it as an addition polymer, then you're attaching two more hydrogens. Doesn't that change the ratio of hydrogen to carbons?
You're attaching two more hydrogens?
For example, if you're expanding this and you're adding a hydrogens, when I have a double bond, I don't have as many hydrogens as I have when I make it a single bond, right?
Not really in this particular case. So let's say instead of me making ethene, I've made 2 repeat units of polyethene, and this is n times. So technically speaking, since it's supposed to go on for forever, you'd not no particular hydrogen would be attached. Like pehle kya tha? Pehle it was just this.
But my question is, do you consider an end of the chain in this type of question?
I do not believe so, because technically these are just supposed to go on till, like, I mean, really, really large values till you. I don't think you consider the end. I understand your point. You're like, kabhi na kabhi this chain is supposed to end, and hence it would be a high H here and an H here. But I'm not 100% sure. We'll find out when we check our answers. But I do not feel that you consider that end of the chain. I think you just take it for granted that this continues forever. It's a polymer, and you just conclude with how the empirical formula is the same as the monomer. So interesting question so far, anyways. nice question. Anyhow, so if 2 and 3 are correct, do we even have any options if 2 and 3 are correct? So you could either have C,
Yes, that's C
you could either have
or
A,
A.
depending on um, whether 1 is correct. Um, I would, if I had to guess, which unfortunately I do at this point, I would go with 1 as well, because like, I mean, you do have chlorine, you do have hydrogen, you have if you're heating this, you're combusting this, your carbons are going to attach with your your carbons are attaching with the oxygen. Some hydrogens are making water. I don't find it difficult to believe a hydrogen and a chlorine can attach and form HCl. Again, HCl is a gas, so that's. I mean, for me, I find it believable. Like at least some form, some choti moti yield ho sakti hai. So, what would you say?
I think it's definitely possible. Hydrogen chloride, that's also my guess.
Yeah, so we can take this, we can do A, and the good thing is if we agree that 1 is correct, um, no, yeah, that doesn't for sure give us that fact that 3 is correct. Anyhow, well, 37 was a nice question. Let's hope we get it right. We'll see later on. Anyhow, so organic compound X gives a precipitate when warmed with um, aqueous silver nitrate. Just a second. Let me just rub this rubbish. Okay. So silver nitrate, so that's AgNO3, and it gives a precipitate when warmed. This precipitate dissolves when concentrated aqueous ammonia is added. So what was the test for? So which precipitate is this? Do you remember? Is it AgCl?
Yeah, this is Ag. If it's silver nitrate, then it's synonymous with either silver chloride, silver bromide, or silver iodide. That's the precipitate. And when you're adding aqueous ammonia in concentrated forms, the idea is chlorine will dissolve, obviously. The bromide ion will dissolve if it's concentrated. In dilute, it will dissolve partially, and iodine won't dissolve at all.
Okay, okay. So so basically this can either be AgCl, it can either be
Yeah.
AgBr, but
B.
it cannot be AgI, because AgI
Yeah.
won't dissolve. Anyhow, so
Yeah.
what could X be? 1 bromopropane. Well, I believe that's fine, because the Br from here can attach with the Ag, form a precipitate and dissolve. Chloro should also be fine. However, iodo should not be fine. That gives you B.
Yeah.
Okay. Propanol reacts with hydrogen cyanide to form 2-hydroxybutanol, to form this basically. A suitable catalyst for this reaction is sodium cyanide, because again you basically need to provide cyanide ions, because HCN doesn't dissociate as readily as you'd want to. Anyhow, which statements about the reaction of the propanol with HCN are correct? HCN is a weak nucleophile, then the nucleophile provided by NaCN, which is fine, because HCN does not dissociate that quickly. It's an acid, it's a weak acid, think of it like that. NaCN dissociates pretty quickly, it's pretty ionic, so it provides you with CN ions, which is basically a nucleophile, pretty quickly. And so I would say NaCN is a stronger nucleophile. The reaction mechanism involves 2 steps, which is also fine. If you remember, if I draw this, I'm not going to draw the rest of it. Let's make a box here. So what used to happen first is that CN comes and attaches here, which kind of gives you O negative, and then the H positive used to come in the second step and come and attach with the O negative. Excuse the bad handwriting, bad drawing. So I can take 2. The product of the reaction has a chiral carbon atom. I would agree, because you can look at the product here. So this is C. It has 1 H, it has 1 OH, it has 1 CN, and it has one ethyl group. So this one you can conclude with A. The structure of lactic acid is shown. Which esters might form when lactic acid is heated? So it's just heated, it's going to form with itself. So if you look here, So this is a carboxylic acid group, and this is an OH. And obviously, understand there won't be just one molecule of lactic acid in a sample. You would have multiple molecules. So it could bond with itself, it could bond with another molecule, whatever. And the chain is basically CCH, CH3. So CH3, so CH3, CH, the OH here, and there's a carboxylic, and here is the ester linkage. And it's with CH, it has a CH3, it has a carboxylic acid. I believe 1 is fine, because what's basically happened with 1 is that this has bonded with the OH of another molecule of lactic acid. Maybe drawing it out would help. I'm a little too lazy to do it at the moment. Let's try to look for question 2. Or let's just go skip directly to question to the third statement, because that should give you a good idea. So this is your ester linkage. This is fine. So this means this is basically this particular part of the chain, and it has your OH. And now you have this, and I don't understand where they got this dabba from, because the OH group is there. Now, clearly, if you think about it, this what I'm circling with blue is basically, let's say, this part, which means that the acid reacted. So if the acid reacted, it would have had to react with the alcohol of the other molecule of lactic acid. It hasn't reacted with the alcohol. It's reacted with God knows what here. So which is why you can just cross out 3. We still have to look at 2 though, right? So
yeah,
let's look at 2. But anyhow, so 2 suggests that you have this particular chain. If you hydrolyze it, this would become 1 unit. This would become an alcohol, and this would go like this. So you have 2 particular molecules, and they seem fine to me. The way I'm looking at it, is just, imagine if you hydrolyze 2. Does it work, or does it work then, or does it not work then? I believe it works, because this would be 1, and this would be the second. Hamza, do you agree?
My screen hasn't shown what you're doing yet, but sounds perfect to me so far.
On your screen, would you objectively agree is 2 that 2 is also correct?
Yeah, I agree 2 is correct in my opinion.
So that gives us
for
what?
another reason than you, but yeah, it's correct.
So what does it give us? That gives us B.
Yeah, that gives us B.
All right.
1 and 2 are correct.
So let's quickly check our answers. All right. So surprisingly, all questions for this were all our answers were right, and that's it for this particular paper. Hopefully that helped. If it did, do check out the videos we have for AS Physics, and if you have economics, AS Economics as well. All right. That's it from our end.